All right, this is chapter 2. This chapter is about time value of money. You can see the title of the chapter, how to calculate present values. Let me emphasize that this chapter is very critical because in chapter 3 and chapter 4 we're going to talk about bond valuation and stock valuation, and we're going to borrow many concepts from chapter 2, so you have to be very proficient in chapter 2, otherwise you have a hard time in chapter 3, chapter 4, and later chapters. Alright, in chapter 2 you're going to see the following topics: future values and present values, perpetuities and annuities, growing perpetuities and annuities, how interest is paid and quoted. Well, first of all, you have to understand the meaning of present value, right? The present value is value today, right now, right? So that's what you have today. Future value is by definition something in the future. So you recognize that $1 today is not the same as $1, let's say 1 year from now, right? So $1 today would be present value, and $1 1 year from now would be a future value. Well, first of all, let me explain how to compute the future value. For example, if you have a present value of $100, right, and you would like to get the future value, how do you get the future value? It's very simple. So what you do is you have $100, which is the present value, and you have it multiplied by 1 plus r to the tth power. So it's 1 plus r, and then raised to the power of t. T is the number of periods, number of years, number of months, number of weeks, whatever it is. It's number of periods. Let me show you one example. For example, let me give you a realistic example. If you have $100 today, right, and let's say you make a deposit into a bank account, you deposit $100, and the bank promises to pay you 7% a year. The question is, if you wait for 2 years and then you go to the bank and you demand your money back, how much money should you get after 2 years at 7% a year? So it's very simple. The future value that you should get after 2 years would be, well, first of all, you begin with $100, right? And then after 1 year you get 7%, which is $7. So your principal becomes $107, right? And then in the second year you get 7% more, so it's 7% of 107. So mathematically it would be 100 times 1.07 times 1.07, and the result is 114 and 49 cents. Now, if you look at this picture, you see that as time passes by, your future value will increase, right? And it's a function of what interest rate you are compounding. So as you can see, when you have a high interest rate like 15%, then your future value will go up much faster than if your interest rate is only 5% or 10%. If you look at the the lowest line right here, this is when the interest rate is 0. So that means it doesn't change at all. There's no compounding at all. You can see it's a flat line, right? Well, let me give you one application of this concept. For example, if you are considering an investment project, let's say you are considering a construction of a building the construction would cost you $370,000, right? That's C0, so that's cash flow at time 0. That means you have to invest $370,000 today, right? In return, 1 year from now, you think that you will get $420,000 in return 1 year from now, so that would be C1, right? So C1 is a cash flow at time 1. And then you estimate the opportunity cost of capital. So the question is, if you were not investing in this project, if you invested your money somewhere else, what kind of return would you get? And let's say that you would get about 5% in return. So the cost of capital is 5%. Alright, so now you have to compute the present value, right? So the present value is C1. C1 is a cash flow at time 1, which is $420,000, right? Divided by 1 plus R. R is the discount rate or the opportunity cost of capital. In this particular example, it's 1.05, right? So you have $420,000 divided by 1.05, and the result is $400,000, right? That's the present value of the cash flow that you are expected to get 1 year from now, right? Finally, you have to compute the NPV. NPV is a net present value, right? And you know that the initial investment is $370,000 right here, and the present value of the cash flow that you expect to get 1 year from now is $400,000. So the net present value of this project would be the difference between these two numbers, and it's $30,000. So obviously this is an attractive project because you have a positive NPV, right? If you have a positive NPV, you should accept the project. On the other hand, if you have a negative NPV, then it's not a profitable project.